All right, what's going on, everybody? It is Kistner, and we are looking at section 3.5 out of your topic 3 in your book. On your student companions, you should be on page 78. Page 78, so pause the video, take time, find that page, and let's get going. Now, this is called zeros of polynomial functions. Now, we've already looked at the zeros of a quadratic. The zeros of a quadratic, remember, were the same thing as its roots, its x-intercepts, its solutions. We had a bunch of different words for it, but they were all, where is the function 0? Where does it cross the x-axis when y is 0? So let's talk about how we do this with polynomials. Now, quadratics, obviously, we could use the quadratic formula. We don't have something fancy called the polynomial formula. So let's talk about this. We're going to factor the function, then use zeros to sketch its graph. So here's our function. F of x or y equals 4x cubed plus 4x squared minus 24x. So the first thing we need to do is figure out how to factor this thing. And what I'm going to do is realize that on this one, and it's really nice, but on this one, I have everything has a 4 in it. Everything's divisible by 4, and every term has an x in it. So I can factor out, so I have f of x equals 4x, and then inside, I have left just x squared plus x minus 6. If you redistribute all of this, you get 4x cubed plus 4x squared minus 24x. Now, what we're going to do now is find the zeros. So I need to set the whole thing equal to 0. I'm just going to rewrite it. And now I'm going to see if I can factor this trinomial, this quadratic. So I have 0 equals 4x times, and I'm looking for something like this. So I think it's going to be x and x, and I need two numbers that are 1 apart, multiply to get 6. So I'm going to use 3 and 2, and it'll be positive 3 and negative 2. Now, we used to not have this term out front, and we would say that the answer would be negative 3 or positive 2, because x plus 3 has to equal 0, or x minus 2 has to equal 0. So now, since we have that 4x there, we're still multiplying all three things. So that means either 4x equals 0, or x minus 3 equals 0, not that, or x plus 3, sorry, or x minus 2 equals 0. And we solve them all. So if you divide by 4 here, you get x equals 0. You solve here, you get negative 3. And you solve here, you get 2. You add 2, minus 3, and so forth. So the zeros of this function are 0, 3, and negative 2. 0, negative 3, and 2. So I'm going to put a point at x equals 0, because I know it crosses the x-axis there. It crosses it at negative 3, which would be somewhere in here, it looks like. And at 2, which is about right there. Now we can use our information that we know about the leading coefficient, which is a positive 4, and it's an odd function. So that means it's going to be coming from the bottom. Remember, odd positives look like this. So it's going to be coming from the bottom. It's going to cross right here. It's going to have to come back down and hit that 0, and then come back down and hit that 0. So there is a sketch of its function, of its graph. Okay? So that's how we use the zeros to sketch it. Because we know we have to cross at each one, and as long as we know the end behavior, there's only one way it could look. Now, let's look at example 2. I can't talk. Understand how a multiple 0 can affect a graph. So now, this right here, if we set this thing equal to 0, we have something weird happening. Ooh, and that's not just the pin that's happening weird. Okay, Now, do the same thing. Either x equals 0, you separate it all. X plus 4, why is it doing this? X equals 0, x plus 4 equals 0, or x minus 1 to the 4th power equals 0. So these are pretty easy. That one's already solved. This is going to give me x equals negative 4. And this, when you take the 4th root of both of them, you end up with x minus 1 equals 0, because the 4th root of 0 is still 0, so you get x equals 1. But here's the problem. My degree here is 6. I have this one, and I have 4 here, so I need at least 6 answers, maybe. Because the degree of this polynomial, if you multiply everything out, is 6. So how do we handle this? Well, we say that 1 here has a multiplicity of 4. Now, here's what we need to know about the multiplicity. We call this thing having a multiplicity of 4 because it came from a term that was to the 4th power. If your multiplicity is even, you have a turning point at the x-axis, at that 0. If it's odd, in this case we don't have that right now, it crosses the x-axis. Okay, and my pen's jumping all over the place, and I don't know why. I apologize. So, down here we have multiplicity of 1, 5, and 2. So this, at 1 here, we will cross the x-axis, and at negative 2, it'll bump the x-axis. So it'll just barely hit right there. Okay? So let's look at example 3. Find the real and complex zeros. So the real zeros, remember, is where this is your x-intercepts. The real zeros are x-intercepts. So I can already identify a real zero. It's right there. But all these bumps here imply that we have complex zeros as well. So let's talk about this. What are the real and complex zeros of the polynomial function shown in the... Now, we learned last class this thing called synthetic division. And all we need for synthetic division is 1 0. This 0 appears to occur at 3. So if I know that a 0, I know that f of 3 is 0. Okay? What that means is a factor is x minus 3. Think about if I set this equal to 0, I get x equals 3. That's what that is. Okay? So I can use this factor and divide this polynomial by it. I can use synthetic division. I can do whatever I need to do, and I will get my other zeros, or I'll get something that I can use to find my other zeros. So let's do that. Remember, if it's a negative 3 in my little box, I put a 3, and then it'll be 2, negative 8, 9, and negative 9. And I'll draw my little line here and drop the 2. 3 times 2 is 6. Negative 8 plus 6 is negative 2. 3 times negative 2 is negative 6. Add those, you get negative 3. 3 times negative 3 is negative 9. And if you... something's off here. Hold on. Alright, I found what's off. This should not be negative 3. This should be positive 3. So make sure, go back and change that to a positive 3. 3 times 3 is positive 9. Gives you a 0. So my remainder is 0. So what I have now is that this f of x equals x minus 3. There's my factor. I factored that out. And what was left was 2x squared. Remember, you always decrease by 1 degree. Minus 2x plus 3. Now this is a quadratic, and I can use the quadratic formula. So here's step 1. Step 2 is to use the quadratic formula, because my imaginary ones are going to come out of this. So if I use the quadratic formula, it'll be plus or minus, x equals negative b, so negative of negative 2 is 2, plus or minus the square root of negative 2 squared minus 4 times 2 times 3 all over 2. Ooh, my pen is messing up. 2 times 2. Now, you simplify all this down, what you're going to get, and I'm not going to take the time to do that right now. You're going to get x equals 1 plus or minus the square, or I times the square root of 5 all over 2. I did that work earlier. Okay, so this is your answer. So you have 3 zeros. You have x equals 3, and then you have these two. You have the plus side and the minus side. Now, I'm going to take the time and do this with you in class next time I see you guys. But make sure you go back and understand how to find the zeros, because we have a lot more examples here. There's actually 3 more examples, but I'm going to take the time and do those in class, or this video would end up being like a 20-minute video. And I'm not going to do that to you guys. Make sure you watch this. Make sure you go back and rewatch the parts that you don't understand. You can ask me any questions on Google Classroom or in class tomorrow or whenever I see you guys. Other than that, I hope you guys are having a great and wonderful day. This is Kistner, out.